You've probably heard the acronym KISS. Keep it simple, stupid. Now, I'll be honest, I don't really like that term. It's a little negative for me. I prefer keep it simple, silly. But principles still apply. Keeping things simple is important. One of the greatest minds ever, Albert Einstein, said, if you can't explain it simply, you don't understand it well enough. Now, I do fully agree, but I also think it's strange that someone of a genius mind would be talking about the virtues of keeping things simple. Is this an anomaly, or is this speaking to a bigger truth? I think this is speaking to a bigger truth. Why do you want to simplify in medical school? Because you do want to simplify. Why? Number one, large volume of information is going to be coming your way. If you can't simplify it, then it's going to be difficult to manage all of it. Medical school is a marathon, not a sprint. And so this is something that is going to be a challenge over time. And so as things get more voluminous, more complex, you're going to have to simplify it even more. How do you effectively recall all that information, all those details? How do you recall it? And do you understand the information? Are you strictly memorizing it? Are you only learning it to the extent that you can answer a multiple choice question? Or are you going to be able to use this information to eventually diagnose and treat patients? And something that I've noticed is that students who struggle with the material and struggle in class often struggle seeing past the details. And it's this weird thing that happens where they are so focused on the details, but at the same time can't learn the details. And as strange as it sounds, a lot of times the best thing for them is to focus on the big picture, to start simple, and then slowly add the details in. One thing I tell students, because it's something that it's hard to, as a student, it can be difficult to say, all right, I'm only going to learn some of this now and I'm going to leave some of the details out to keep it simple, because you do need to know details. However, if you're going to start with all those details, it can be really challenging. And the analogy I use is, if you can juggle 3 balls, juggle 3. Don't try to juggle 12, because you're going to end up with 12 balls on the ground. But with 3, at least you'll be able to keep 3 up. And then maybe someone will throw you another one and then another one. But it's if you are too fixated on the details and you're so engrossed by them and you're failing to learn them, it can be a good idea to step back and take a smaller bite of the information, get some success, get some knowledge, and then build on top of it. And we'll talk about that later in this video. Some benefits of simplification. You get to condense the information. There's so much, you get to reduce it. It's easier to recall simple information versus complex information. It allows you to find patterns. Patterns, rules, these are things that are going to help you not only recall easier, but also potentially understand better. And it's easier to understand something that's put in simple terms, and easier to study and review it. So a lot of benefits of simplification. It's going to essentially make your life a lot easier. Of course, we can't stay simple forever. We're going to talk about building on top of a simple foundation, but it's a lot easier to build details onto a foundation that makes sense versus trying to learn all the details without anything making sense. Few examples of ways to simplify information, and there are others, but one we call one-sheets. It's essentially what it sounds like, but it's also not as rigid as it sounds like. It's one sheet of paper, what you put on that sheet about a lecture, that's your study guide. And so what you have to do is you have to decide what stays and what goes. The important information, the information that was stressed, the information that is foundational, that helps you understand other things, that's definitely going to go on the one sheet, versus information that is more obscure, more lower yield than other information, that's going to stay off of the one sheet. It doesn't have to be one sheet of paper. It doesn't have to be paper. But anything that you're making, the idea is putting something, bringing the content together, but only the most important stuff. We call it high yield information. Only the high yield. So that's one sheet. We'll show some examples here shortly. Whiteboard pictures. There's a lot of whiteboards in SE&M, and the students will often draw out pathways, biochemical pathways, physio pathways, or make tables. And that's also a bit of a one sheet because you're putting everything that you want to study about this topic onto one surface, one piece of paper, one whiteboard. Again, it doesn't have to be one, but what I like about the one thing, even if it's a huge sheet of paper, but having it on one, it helps the brain see it as a unit versus PowerPoints where if you have 50 different slides, it can seem really disjointed to the brain, in my experience. And a little game I call Explain It to a 5-year-old. So how would you explain this lecture, this material, if you're talking to a 5-year-old or a small child who doesn't have the vocabulary to understand the complex scientific terms that you're going to be hearing? How would you explain it to them in everyday terms? What analogies would you use? That can be really effective at taking the information and taking it from a really high scientific level and bringing it down to a level that's understandable, especially when you're first starting out. And another thing I've realized is that if you want to learn something, sometimes the best way to learn is to teach it. Teach it before you know it. Sounds counterintuitive, but when the brain is challenged in that way, it's going to search for meaning, it's going to search for simplicity, it's going to search for patterns, and you may surprise yourself and actually end up explaining it to yourself as you try to teach it. So the Explain It to a 5-year-old game, you don't actually need a 5-year-old to play this game. You can just pretend like you're talking out to a 5-year-old. But how would you explain this material to a child with a limited vocabulary? If you do that, you may find that the material seems a lot simpler after. So let's look at some examples. Here is a one sheet on the thyroid. We can see top left corner, there's a little schematic of how the thyroid hormones relate to the kidneys and the liver. We have a small pathway showing T4 being converted to T3, reverse T3, and then eventually T2. We have other information that's organized, cofactors, testing, and one thing that I like is a lot of colors. So with simplicity, as you take things out, what you can do is you can embed information in colors. I'm not sure if there's any info in the colors here, but I had one classmate that used to take notes, and everything in black was from the notes. Everything in red was something the teacher said, you have to know this. Everything in green was something that they had looked up on the internet. And so there's a whole color coding system. So you can reduce the amount of words, but put in more information if you have a color coding scheme, pictures and symbols, like the thyroid in the top left. That's not what the thyroid looks like, but it's good enough. For me, I used to draw a little flame anytime that there was inflammation in the notes. And so whenever I saw the flame, I thought inflammation. It's a lot easier for my brain to remember the flame than the word inflammation. So this is information. This is a lot of endocrine information, probably several slides worth of information on one piece of paper. It's organized. It looks cool. It's got colors. It's bright. I think the brain likes these types of things versus really bland text. So here's another one. This is a neuro one sheet. You can see the image on the top left corner. That's a cross section of the spinal cord, and you can see with colors and things are numbered and lettered a lot of labels there, and then the labels are written out on the rest of the one sheet. So that one sheet has a lot of information. It has all the different components of the spinal cord if you took a cross section, and this is slides and slides of information all on one piece of paper. It's visually appealing, I think. The information is there. It's densely described, information dense, no wasted terms, and even enough space to talk about upper and lower motor neuron lesions, which is pretty important. There's a lot of information on this one picture. So now let's look at the brachial plexus. These are the nerves that go to the upper extremity. And as we can see here, if you're not familiar with the brachial plexus, that may seem confusing, but there's a lot of information. We can see the nerve levels on the left, C5, C6, C7, C8, T1, and we see a lot of lines, and that's showing how the spinal nerves are merging to form the peripheral nerves that end up in the arm, musculocutaneous, axillary, etc. There's quite a bit of information here, but not as much as this one. This has even more information, and we can see in the bottom left a lot of notes on what nerve levels are supplying them, etc. So this has more information than that one. And so when you're simplifying, what I recommend is start with the most simple, bare bones structure, which could be just the lines basically, and maybe the nerves at the end, and then slowly add in information. Again, that's like juggling 3 balls, because you can juggle 3 and then taking on a 4th and then a 5th over time as you can handle it. So don't jump to everything. So this right here, this has a lot of information. This is a really good, clean one sheet. You don't have to start here. You can start here, or even simpler, and then build to this, and then add a little more information, and then add a little more information. I think that's a really good way to approach it, because if you start with something simple that you can learn easily, once you have that in your brain, now you can attach other things to it. And so it's really important to have something in your memory to link what you're learning to, because it's a lot harder to learn something in a vacuum than it is to connect something that you don't know to something that you do know. So on top of this is really dense information, couple hours of perhaps of lecture right here, a lot of information. If you can decode this picture, you can figure out just by drawing this out what nerve root levels supply each nerve for the most part. And so it's just so dense with information, and it takes away how much you need to memorize. Because if you can draw this out and be able to figure based on where the line's going that, okay, musculocutaneous is C5, C6, and maybe some C7, but it's not C8 and T1, then you don't have to memorize that because you can figure it out just by drawing the picture. Some how-to tips for simplifying. Number 1 is to chunk. So group, organize things based on similarity. Come up with analogies. Analogies are very useful. Again, if there's something that you can picture already and then you can relate what you're learning to that, that's going to be very useful in learning and putting that into your long-term memory. Use everyday language. Of course, you do need to know the terms, and you eventually want to be fluent in Latin and Greek, especially the medical side of it, but you'll also want to be able to go back and forth, because you're going to want to use the medical language with other medical professionals, but you're also going to want to be able to use everyday language with your patients. Docere, to teach, this is one of the principles of naturopathic medicine, and it's really hard to teach if you can't put things in lay terms. You're going to have a hard time teaching people that aren't professionals. Use symbols if you can to replace words. Words are tougher to remember than shapes. Minimalism, take out as much as you can. I took out a lot of information. Even if there's some information, I'll be honest, I thought I'm not even going to try to learn that because that looks way too much for me, and I doubt there's going to be a question on it, and I don't think it's going to be important as a doctor. So there were times that I thought that, and I thought, all right, I'm not even going to learn it. But there are other times I thought, okay, I acknowledge that this is going to be important, but I'm not going to learn it now. I can only handle this much. And even if you go out to eat and you're eating a big meal, you still have to take normal sized bites. Doesn't mean you take bigger bites or you swallow it all whole. No, even if you have more to process, you still have to take bite-sized pieces. And ditch the PowerPoints. PowerPoints are made as presenting tools, not as a tool to deliver large volumes of information. And I think it's also, PowerPoints can be confusing, I believe, to the brain, where it seems like all of these are separate topics, but you may have 5 slides or a lot more on the same thing. And so all of that should be condensed to one. So for example, if you're learning about, I'll use a cardiac cycle examples. You're going to want to get all of the cardiac cycle slides onto one page, because that's going to help you see the big picture, and be able to see how things relate to one another. It's going to be a lot easier to remember. So using the cardiac cycle as an example, we can talk about using everyday language. What is the cardiac cycle? That's one of the first things I ask myself. What is this? In simple terms, what is the cardiac cycle? Well, it's just the heart beating. It beats, it relaxes, it beats, it relaxes, etc. That's the cardiac cycle. So now you have that understanding. Now you start to connect the terms. Well, what is the term for the beat? That's systole. Okay, what's the term for when the heart's relaxing? That's diastole. Dia meaning between, so it's between systole, between beats. So in that way, we can start from these simple lay terms of what's happening, and then start to add the scientific details to explain it. And then you can go even further. Okay, how does systole occur? Well, it happens from an action potential. Okay, what generates it? Where does it travel? And so now all of these details, you can now start adding layer by layer in order to create the picture and to describe what you already know is happening, which is the heart is beating. So that's where I've talked about starting with a simple foundation and then adding the details and using them to explain that simple function or whatever it is, explain the how and the why of something that you understand in simple terms. Now, of course, as you do that, you're going to realize that there is nuance, that the simple solution isn't always right, that there are some maybe overcorrections. There are things that happen when you simplify. You lose information, sure. But that's why you don't stay simple. You start simple as a bit of a rough draft, and also a way, again, to be able to teach people and to understand what you're learning, but then you take the details and you use them to color in the lines and to fill in the gaps of how and why and where and all of that nuance that you do need to learn. That is easy to build on after the simplicity. And even if you know the details and you can learn them without simplifying it, I do not recommend learning the details and not seeking simplicity and not seeking that understanding, because as time goes on, you're going to learn more and more and more, and you're going to have to use this information in more and more challenging ways. It's not going to be multiple choice tests forever, right? You know that. And so this, by being able to simplify, you'll be able to problem solve better as well. 80-20 rule is pretty important. 80% of your time will be used to learn 20% of the information, and 20% of your time is going to be spent using 80% of the information. I'm definitely a work smarter, not harder type of person. And so I I'd rather spend 20% of time worrying about the 80% and then the other 20% try to learn what I can, but not stress about it. And that I found was pretty useful because it is important to maintain balance in medical school. So much is happening and not just class related. Life is happening as well, so you don't want to burn yourself out on studying. And so you want to focus on the content that's going to give you the biggest return for your effort. So this includes things like high yield information that is really likely to be tested on. This also includes information that helps you learn or understand other things. And so if learning about a concept or a detail, if that brings understanding to other concepts, well, that's a good thing to learn because you're not just learning about that one thing, it's helping you understand others. When you do this, you can free up space and time in your life for other things that aren't school, which is really important because life is not just school, and it shouldn't be just school. There should be other things in your life, and I'm sure that there are other things in your life, and we want you to have time for them. It may not be as much time as you'd like, but we want you to be able to have some time and not be totally fixated on studying all the time. And in school, balance is better than perfection. Perfection is impossible, first of all. Secondly, it can get in the way of a lot of good things. And so if you're consumed with perfection, then it generally ends up even worse than if you're just trying to do a good job. And so some students who are so fixated on being perfect and knowing all the details, I need to know them all, I need to memorize them all. Well, they generally suffer in one of two ways. Either they don't learn any of them, or they learn very few because they have put so much pressure on their brain and they tried to learn so much all at once that none of it got into their long-term memory. So that's one option, is it just doesn't work. The second option is it may work, but at what cost? They may have health issues, mental emotional issues, depression, anxiety, etc. There's a lot of things that can happen if you burn yourself out studying because it's 4 to 5 years, depending on which of the programs you go into. So to apply, start simple and add details as you go. I think I have a slide on this coming next. So start with a simple foundation and then slowly add details. As you understand another layer, throw on another layer. As you understand that layer, throw on another layer. Don't try to study everything all at once. Start with the end result or the end goal or function in mind, like with the cardiac cycle. You know it's the heartbeat. This is the heartbeat. So everything that you're learning about the cardiac cycle is teaching you about the heartbeat. So just use that simple foundation to explain, to be able to explain, justify, and understand the details. 80-20 rule. Start with the 20%. Start with the 80%. That's only going to take 20% of your energy, of your time. But you could even start with less than that. I think when I was studying, I probably would start with 20%, 20 to 40 maybe. Depends on how well I knew it. The less I knew, the less I would start with. And that leads us to the last recommendation. Don't get stuck in the weeds with minute details before you understand the big picture. If the details aren't going to make sense, then all the best you can do is memorize. And there are times, obviously you do have to memorize, and there's some times where there isn't really much to understand, so all you can do is memorize. But if you over-rely on memorizing rather than understanding, A, really taxing for the brain. There's only so much you can just brute force memorize. And B, just because you have it memorized doesn't mean you'll be able to use that information in clinic. And for those of you who want to become clinicians and doctors, the most important thing is how you use the information. It's not just knowing it. Nobody cares about your grade. It only matters, can you use this information to diagnose and treat people with issues? So don't get caught up in the weeds too early. Yes, you do need to know details, but I'll be honest, in my experience, the students who really struggle, again, this is my experience, a lot of times it's not because they're missing some fringe details. It's because they're missing huge things. If you ask them a simple question, they can't give you an answer. So, yes, it is important to know details, but not every detail. But even more important is to have that simple foundation, because A, without it, it's going to be hard to learn the details. B, even if you learn the details, if you don't have that simple foundation, it's going to be really hard to use it. Okay, this was the image that I was looking for, or hoping for. This is it's tough to see, but this was a biochem pathway. You can see starting at glucose at the top, we have glycolysis moving down, and then we have the TCA cycle. This is actually me connecting several pathways because I just want to see where everything came together. And so with this, I don't even have the full words for a lot of things, and I don't have the enzymes. So this is the bare bones, and actually the way I learned glycolysis the first time is how I wrote it out there at the top through from glucose to pyruvate, is I just wrote down, I gave them all acronyms, right, letters and numbers based on what their name is, but I simplified and write out the whole name, glucose 6-phosphate, just G6P, and then F6P and F16BP. And then, so I started with that. And once I had that down, then I went in, then I went in another layer further. Okay, what is happening each step? Okay, we're going from a G to an F. It's glucose to fructose. They're isomers. And so that's got to be some sort of isomerase, right? Anything that's adding an ATP is going to be some type of kinase. So you can start to fill in the enzymes. And then once you know the enzyme names, you also know what's happening. So those two kind of go together. And in this way, you can slowly add enzymes, cofactors, etc., and put details on one layer at a time versus trying to study everything at once. So this could be, at least the glucose to the pyruvate, could be could be the first version, and then something like this, where now we have the enzymes and even have the number of carbons and where they're being cleaved. That's where you can go next. This could be the second or third level as you're building on top of it. So that's an example of starting simple, and then you can increase with the complexity and the layers of details as you go along. But start with something you can manage. Success breeds success. If you start with failure and you start with overwhelming yourself, it can be tough to get out of that. But if you start with a little success and then you add a little more success and a little more, eventually you're going to be doing really well. With everything we talked about with simplicity, there is this caveat. Everything should be made as simple as possible, but not simpler, said by the same Albert Einstein. And so that, yes, there is, as I mentioned before, there's a challenge of simplifying things, but also still maintaining truth to what's happening, because you can oversimplify things to the point where that they're inaccurate. But of course, the simplicity, as I mentioned, is just there as the foundation and to help teach your future patients. But I don't want you to have just a simple understanding forever. I want you to have a complex understanding, as I'm sure you want for yourself, with details, with nuance, but resting on a simple foundation, because that's going to be easier to learn from, to act on, and to teach from as well. So in summary, gotta use both of Albert Einstein's quotes. If you can't explain it simply, you don't understand it well enough. So if you're struggling, whenever I struggle, that's why I thought, okay, what is happening in one sentence? What is this? How do I put this as simple as possible? And then once I have that, then I'm using that simple understanding as a sort of rubric, in a sense, that now as I'm looking at the details, I'm comparing them with that simple explanation and seeing how those details fit into it. And in that way, I can understand the details better. But while you're simplifying, everything should be made as simple as possible, but no simpler. So don't oversimplify, and also when you're simplifying, I think it's also good to remind yourself that you're simplifying. And so this is a simple understanding that you're going to build on. So yeah, start with that simple base and use the details to understand more, how and why and all the details. Don't try to learn everything at once. Not a good idea. Start with what you can manage. And some days that's going to be less than other days. When it came to board time, I could only learn 1 or 2 things at a time. I could not do too much. My brain was exhausted. And so I just scaled down on how much I was handling. I couldn't take as big of bites. Look for patterns, rules, and analogies. Patterns going to help simplify things. If you notice a pattern, then you don't have to study it multiple times. You just study it that once. Same thing with rules. If something's a rule, then you can understand the rule, and that's going to teach you a lot of things in itself and help you understand potentially several different concepts. And analogies are just the symbolic nature, can help us understand things that when the details fade out of our brain, because remember, you got to keep this information in your brain for years as you're taking boards and whatnot. As the information, the details are fading from your brain, the analogy can still remain. And that's important because you want to think about, what am I going to remember year 2 or 3, depending on which program you're on. What are you going to remember a year or 2 after you take anatomy class, when you now have to study all that for boards? If you don't have any sort of simple foundation, if you're only just memorizing details, you're not going to have much unless you're a super genius, you're not going to remember much. But all of those rules, patterns, analogies, the simple understanding, that has a much greater chance of remaining. Also use everyday language to explain scientific concepts. That's one way to make this information more relatable. Reduce the verbiage in your notes. Replace words with symbols, pictures, and colors. Words take up space, and they're also not that memorable. So the more that you can draw things out and reduce the amount of words, draw arrows, all of this is going to help you condense the information, which is going to make it easier to learn and recall. And lastly, you can only find simplicity if you seek it. So if you aren't looking for the simple solution, you're probably not going to find it, and then things can be needlessly complex. And I do think that while there is a complexity to nature, I think nature is also remarkably simple. And humans are pretty good at making it complex. So as a human that will tend to make things complex, it's your nature, just like all of us, try to balance that by looking for simple explanations, simple solutions. Are there any patterns, or are there any rules? How do I take this content and translate it in a way where that even a small child could understand? If you're asking those questions and seeking that out, then you're more likely to find simplicity in the information. You're going to learn it easier. You're going to learn it faster. It's going to be maintaining your long-term memory for longer, and you're going to be better equipped to understand and to use it to help people in your patients.